Hey guys, Average Joe here, and I am back with my Bowflex Selecttech 552 Disc Fix 3D models. In this video, I'll be explaining the models themselves and comparison with the OEM parts. Here you can see one of the discs and its corresponding model. This is the pin style as opposed to the original lip style. But I'll go into various aspects of changes that I made to improve on that OEM part. So first, let's take a look at the two models. This one I refer to as the pin style because of its use of pins. These holes are drilled through the part, and then a rod is cut into sections with the edges chamfered, and they're pressed into these holes. This is a little bit less expensive to make, primarily because you can turn this part on a lathe, and then you can drill the holes and press your pins into the various holes versus having to CNC machine these parts. So meaning, like a 3-axis machine or something along those lines. Anyway, it's a little bit cheaper to make this part, but you get the same result. Now, the original model that I did was actually based more closely on OEM. It uses a perimeter lip, just like OEM. One of the main differences is you can see here when you stick this disc in the frame, it is designed to basically hug the retainer here along the outer edge of the disc, which is unnecessary. It's just the way they happen to design the part. What I've done is I've shrunk the part. So I've basically made it a slightly smaller diameter. I didn't really need to have this full diameter. It's a waste of material, and it's unnecessary for the part itself. So these are a smaller diameter than these. So that is why when you look at this model, you can see that the lip here is a much thinner lip than here, because the diameter of this part is smaller than the diameter of this part. So anyway, that's one change. The second change is you can see a shoulder right here all the way around 360 degrees. This is what it looks like on a finished part. And here there is no shoulder. That is a bevel. What that means for, let me go grab the weight. I'm going to show you why this is important. Okay, so here we have the weight, and we're going to slide this weight onto the part. And in its current form, you can see this weight can rock back and forth because it has no support along here. There's nothing to keep the weight from rocking in the frame. But by adding a shoulder all the way around, when you slide this onto this assembly, it can't rock now in this frame. It sits supported here and along the backside here. So there will be no more rocking in the frame. That's part of what contributed to the noisiness of the dumbbells, but it's also part of what contributed to the failure of the discs, because eventually, as those weights rock in the frame, they're putting stress on these discs, and they're causing all these different kinds of failures. So that is why I added a shoulder, and that shoulder height is the same height as the pin. So this functions like a, think of it like a tabletop, right? This height and this height is the same, and so the weight sits uniformly on this entire assembly. It doesn't make a difference that there are no pins here. Same thing on this part. There are no pins on about 270 degrees of this part, but there is support here on the shoulder to make sure that that weight does not rock on this disc. So that's the second change. The third is the use of pins to align the various pieces. So these pins serve as alignment, because these need to be perfectly aligned with very particular angles for each disc. And you don't need this style. They did this probably because they molded the part. But, when you're molding a part, then it doesn't make a difference really what you're doing here. It's whatever the mold is what the part's going to look like. There's not an extra step having to machine all of this. So, they use this style, and you can see on the back here, they have that style, and it works. It works for their design, but it's unnecessarily complicated if you're going to do a metal replacement part. Instead, I went with pins. Now, I could have gotten away with one pin because the center shaft acts as a locator, and one pin would be enough to keep all the parts aligned. Two if you really wanted to do extra. I did 4, primarily because let's see, let me grab this. On this part, which is part of the OEM assembly, I needed to have 4 pins for this. Or I shouldn't say I needed to have, but I decided to have 4 pins for this so that the part could engage this plate just like factory. Okay, so it engages this plate the same way slots would, but using just pins. And in order to make the parts easy to manufacture, rather than having each one of these discs have a different number of pins or a different arrangement of pins, I created it so that they all have the same style. That way, when this part is made on a lathe, all of the drilling locations are basically the same for all of these discs. The only thing that varies is the height of the boss on the discs. And then in the next step, they basically can put this on a drill press or any kind of CNC table and drill the holes for the pins at each of the particular XY coordinates for the pins. But basically, all of the main discs are made the same. It's just for uniformity. It's for ease of manufacture. Same jigs for this stuff. Okay, so I talked about the shoulder. I talked about the pins and the diameter. Also, the thickness. If you look here, so these are the same parts, okay? But if you look here and we align the pins with the height of the lip, you can see on the back side here that the thickness of the disc is considerably more. Now, I didn't have to do this. In fact, I could have made this disc a lot thinner. I added material on the back so that I could take up some of the gap between the parts. So if by adding material here on the back side of this disc, I'm closing the gap from this pin to the back of the next disc, so on and so forth, right? So when you stack these like this, you can see here, let's see, let me grab a pencil. You can see here that the distance from this pin to the back of that disc and from this pin to the back of that disc is now smaller because I made this thicker. And that means that when you slip your plates in here, they're not going to have as much play inside this gap as they do on the factory discs. So again, this had to do with making it stronger, making it less noisy, making it less prone to failure. These aluminum discs, I could have made them much thinner, much lighter. I could have made this boss here, for example, even a thinner diameter. And maybe down the road, I'll toy with that a little bit and, experiment with it and see what I can do to improve the design. But, this was basically my second, this pin design was my second design of the model. Now, this, I think I mentioned earlier, these parts would have to be CNC milled in order to get the lip on here. There might be somebody out there that can do this on a lathe and combine it with some other procedure, like putting it on a lathe, lathing the entire, or milling the entire lip, and then milling off the section that you don't need. I'm sure there's a variety of ways to accomplish this, but I do like this design. I wish I could have done this design, but to do a prototype set of these discs was extremely expensive, like $800 for one set of discs. So I did a second design. And in this second design, I basically modified it so that I use pins where the lips would have been. And these pins aren't just in arbitrary locations. These pins are very specifically located, such that the pin itself, each pin engages this tab dead center. So when this is in the frame, what you want is if you can see that there's the tab. The pin will engage the tab dead center. And as you rotate to select, it'll engage dead center, and then when it doesn't engage, of course, you can slide the weight out of the frame. Okay? So these are very specific locations. The angle between each pin is 24 degrees, and that is true for every single one of these pins. So between here, 24, 24, 48, 24, etc. It's all multiples of 24. One other thing I should mention, I originally wanted to mill out some of the weight on the back of this disc. The reason I left it thick without milling out any of this additional material, this unneeded material, is because it's another operation. The more operations you do, the more expensive the part is going to be to manufacture. So, we don't want to add unnecessary expense. Notice that, I didn't chamfer this, didn't chamfer, no radius. This is just sanded quick in order to remove burrs. These pins are chamfered. I'll explain that in a second, but there's no chamfer here, and there's none on this lip. Basically, this part has as few operations as possible in order to create the part. Nothing unnecessary. I could make a much more beautiful part like the other one that I showed you, but this requires more operations. In fact, I was trying originally to get rid of, of this. I really wanted to get rid of this, the need to make this particular disc unique. Remember what I showed you? My other discs are like this, but this disc had to be like this. And the reason is the OEM selector. Unless I make a new selector, this part has to fit this selector. And this style is not going to work. So I had no choice. I had to make this one like this. Ideally, I would redesign this part, and I would redesign this part to get rid of this stupidity. But, you know, that's the way they did it. And unless I want to make an even more expensive kit, I left these as is. I could probably redesign this entire dumbbell and make it better. But, you know, who's going to pay for it? And frankly, you know, Bowflex at that point, you know, you don't want to deal with their attorneys. Okay, so the chamfer on the pins. Why? Well, when you close the gap between these discs, okay? Let me grab these discs here. When you close this gap and make it tighter, now you've got a problem that this is a plastic coated weight. This is not metal, right? It's just got a thin plastic covering on it. When you're sliding this in and out of the frame, you don't want the edges of these pins to gouge this plastic. The tolerance is so tight on these that you can actually see these lines? This is from my pins. If I didn't chamfer the pins, it would scrape this plastic even more than what it is right now. I wish they wouldn't have done plastic coated parts. I wish they would have done just, you know, cast iron with powder coating or something. But I have to, again, work with the OEM parts. And you can see on both sides that shine is where the pins, these pins, are riding the plastic each time in and out. So, you know, you have to put some sort of chamfer or radius on your pins so that they're not digging into your plastic. I think that's pretty much it. You know, making sure you got the right thickness, making sure that the pin heights are correct, making sure that the gap between this disc and the next disc is correct, adding a shoulder to add support for the weights so that they don't rattle around in the frame, simplifying the way that your discs engage each other so that they all remain in alignment, and trying to keep the weight as low as possible without adding too many operations to increase the cost of the part. And these two models, I mean, right now, based on testing this prototype, I would make small adjustments in this. I'd probably remove, for example, a 0.5 millimeter from the thickness on these parts. I'd probably just, you know, go a tiny smidge smaller. But, you know, it depends. If there's enough interest in this, then I can make the necessary modifications and, you know, offer up a model that has all the you know, improvements already in the model. Right now, this model is this part. And like I said, you know, there are some improvements that I could even make on this part. Oh, one other thing. I mentioned in the previous video about this inner circumference or inner diameter. Okay, so inside here, the shaft that this slides onto is not uniform along its length. So when you try to install these parts on the OEM shaft, you're going to probably have to sand the shaft just a little bit, but to get some of that lack of uniform diameter off of there so that this slides on more easily. Otherwise, what's going to happen is you're going to try to slide this on and it's going to bind on the shaft. And I know that because all 4 packs of discs, all 16 discs, bound on the shafts of mine because the tolerance of this design is really tight. I didn't want this to basically, you know, rattle around on the OEM shaft. So that's it. Hopefully, a little long-winded. I wish I could have made the video shorter, but hopefully now you understand some of the design choices that I made and why I have two models. If you guys are interested in, actually creating this part, not just for yourself, but I mean, coming together as a group and creating these parts so that we can all buy them at a much lower cost, then I would love to pursue that. Right now, this set cost $350, and that was from a friend. Had I not been able to use his services, chances are creating this set would have cost more, like $600-700 from a professional machine shop. But he was able to create this for me for $350, all 16 discs. And to have these made overseas, I could probably have these parts, either this design or this design, made for probably about $8 to $9 per part, my cost. But that would be for a minimum of 500 sets. That's about $80,000 just to get the manufacturer to make 500 sets of 16 discs. So, it's no small amount of money. But again, if one of you out there, wants to collaborate and try to introduce this to the market, then get a hold of me, and I can use my design plus my contacts in the manufacturing industry, and I just need people who are willing to go out and let their friends know. Let other people who own Bowflex Selecttech products know that this thing exists. I just don't have the time to do that. So anyway, hopefully this answered your questions. If you have any other questions, leave them down below in the comments, and I will try to answer your questions when I have time. And thanks for watching.